Hello folks, time once again to do a retro CSS battle. These are CSS battles from CSSBattle.dev from the past. These are from August of 2024, August 1st, the 2nd, the 3rd, and the 4th. I try to learn something every time I do these. It's experimental. I try to take a new approach each time. So let's get right to them. I think today on this guy, I'm going to try the nested template, which is using the HTML and the body tags, which are implicitly there to get this shape. So let's do it. So the background is this purple, and then the background of this one is this lighter color. So this is where we start, and this is the diff. Using margins, we will try to constrain this so that the body tag has the right shape, and it looks like a margin of 42 does it. So that's what we get. So what's the simplest way to approach this shape? Today, you know what's interesting is that I suddenly see that this could be done with some box shadows. I don't think that's on the table for us here, but I will go with my classic conic, classic, I mean I'm saying classic, but conic gradient. Two conic gradients. We'll do this. And it's, what is it? It's from 90 degrees, and then it's transparent, 25%, and then it's this brighter color. So you can see that. And then if I put it in the upper corner, which it already is, and then give it a height and a width, is it 100 pixels? And then no repeat. There it is. So let's do another one of those, because it's very, very similar. And instead of 0, 0 as the background position, this is 100%, 100%. And instead of from 90 degrees, it's, we don't need that. And we're going to flop these colors. In this case, the lighter purpley lavender, and then make it 75%. And let's submit that. And that's one way to do it. There are other ways to do this one for sure. I definitely think that you could get a long way with doing borders on the body. Lots of ways to do this one, but we did get 100% match. So let's unit replace and minify, and we're all done here. And then my minification code. Stuff this 75% next to this, and that's no good. We gotta fix that. All right, so we fixed it. Great. Next. All right, so there's that guy. All right, next. This guy's so interesting. This makes me want to use successive transforms on a paragraph element. So I'm going to use my blank template, which is a paragraph tag, and we'll set this color of the background. Our margins, I think, are 0. Yeah, margin is 0, and then we'll give this a width, or aspect ratio 1. Okay, and then so for what I'm trying to do, I'm going to do a display flex. Align on, no, I'm not going to do that. Let's use margins. So I was going to try and do a line of elements here using flex, but I think that's not going to work for my case because it's going to squish them. I might be wrong about that. Regardless, there's 100 pixel margin, 5, 6, and then let's make this a little lighter, 2, 3, 4, 5, 6, 7, 8. So that looks like what my circle is. So if I do a radial gradient, radial border radius is what I want. Ha ha ha. Border radius. of 50%, I can make that a circle. The question is, what's next? If I have a second one of these, is it possible to successively shrink it and move it? And is this a line of a sequence that would be interesting? And if so, what do I need to do that? So I kind of want to make this display fixed. Okay. And then top 60 and left 0. And is that even working? I'm not sure that's working. Okay, so another housekeeping bit here. We'll do width of 180. And let's remove the margins from the body, which I think we're not respecting any. Oh, no, we are. No, we are. All right. So here's, it's been so long since I've used position fixed that I forgot it's position and not display. Okay, so that top value is 50, 52 or something, or is it 42? 40, 48, 45, there, 44, 45, 44, 45, 46, 44, 45, there, okay, so 45. All right, so now they're all in the same position. So is there a selector, or do I need to variabilize it to transform this? So to scale, let's do a background of red. So that's on top of that one. Scale 0.8, let's say, or 0.9, or 9.5, and then we translate. Translate on the x-axis minus 100 pixels. Oh, whoops. Translate. Oh, so we want transform, probably. Transform. Translate, and then that's parens. And then we want a positive number. 50, 60, 70, 80, 90, 70. So that's conceptually what I'm trying to do there. All right. So how do we do this? Do we need to translate a little bit more? 5, 6. So I'm playing with the numbers. There we go. 89. That looks dead on. Unfortunately, that's not a really great thing there. So let's give this a B attribute. And then let's see what C would be. So we'll make another one and say, what's the scale on this one to get this, to get that third one? Scale, we'll just copy them. Haha. Make sure we're applying this the correct style. There's the next one. 50, 60, 70, 80, 90. And is that 8, 7, 9, 7, 8, 91. So this is a tricky way to do it, but it seems to be sort of working. I'm curious to see whether I can get it to work. I would love there to be an algebraic formula that I can use and apply. But probably the best I'm going to do is be able to variabilize this for each successive one. Is there a pattern? There might be a pattern, actually. This would be 67. And then 2, 3, 310, 309. It's close. This might not be a great idea. It's kind of working. let's do the final one, which is E, and see if we can make it work. Really, you know, a lot of coding is, hey, keep trying things until it works, which is totally legit. 4, 5, 4, 8, 4, 9, 4, 7, 4, 7, 5. Let's submit that. I bet that's not a 100% match. If it is, I'll be surprised, but not totally surprised. Yeah, 99.7%. So yeah, we're not really in the zone there. So do we tweak these numbers and stick with this approach? That's the question I find myself asking. Is that too big? I think it's too big. Move it over more. Okay. Each one of these. So this is where it's really, maybe this is not a great approach. And if we're already scaling, so rather than this, I'm going to stick with the aspect ratio 1 here and not do scale. And I'm going to have this left value be the thing. Var of dash dash. I'm going to do P for position rather than L for left because the lowercase l looks like a 1 and it's going to confuse me and then I'm going to be irritated and that's no good. That's no good. Alright, so the height is a variable as well. Var dash dash h. Okay. All right. One thing that can be helpful for this is to remove the border radius for each one of these. And in fact, it feels a little bit like like that 44.5 top value is actually correct, which is a little irritating. If it's perfectly if the height is 180, it's 120. Is it perfectly centered? 300 minus 180 is an even 120, which would make it 60. Does that make any sense? I don't think that makes any sense. I don't know what I'm talking about here. 180. Be that as it may. Let's do some P for position, and then we'll do 40 over, and then set our height. Okay. Bar H over that. We're not seeing it. Background yellow. We're not seeing that at all. Why? Something about this code is wrong, and I don't know what it is yet. Yeah, I really don't know what that is. I don't know what the problem is. HH, background yellow. Oh, it's actually not wrong. Ha. We need to change the top value as well. That needs to be a variable. That's T for top of 44.5, so we need to set that value as well. T. So let's actually call this left an X and this T a Y. Again, naming variables always a little bit tricky. So top would be a Y variable, and this is the X variable. So you know, you can see it. Great. And that height is not enough. So let's do the X value of 100. Okay, and then down 5, 6, 5. Okay. And strictly speaking, we do need the border radius. The border radius is var dash dash radius or 50%. Alright, this is taking longer than I thought. So we're only going to do that on this one. So we're not big enough. We're not near big enough. If anything, maybe we want to start at the other end because it's a little easier. Maybe. We do alternating because it's just easier to work with. Sure. 7, 8, 81. Yeah, I like this technique. All right, so 81, 82, 83, 84, 85, 86, 85, 84.5. That sure looks right. I really hate it, and if the width of this is 100, then that 300 is a correct number. So then we can undo this border radius, and that's a match. Okay. So does that imply that this middle one, so that now maybe we're looking at a pattern here, 84.5. Let's not get ahead of ourselves here, Crawford. All right, so let's do the middle one. So we did this one, and we'll call this one actually E. And then we'll do B last. So now we'll do C. So we'll do the middle one. So those values. So if it's from 180 to 100, is it 20 each time? Is that right? And if so, is that 140? Okay, and then these numbers, so we're going to do the R0 again. So okay, so our Y value is too high, 6. Okay, and then this X value is less 2. 1, 5. That can't be right, can it? No, it's not centered. So 1.7? That could be. Alright, let's put the... Yes. So there is a pattern. There is a pattern. Okay, it's looking like there's a pattern anyways. Okay, so let's do the next one. So if that's let's see. Now that we've got the leftmost and the rightmost and then the center, we should be able to infer the next one. So it would be halfway between the rest of these, right? So 7, and then 120, and then between 300 and 170 is what? Let's just experiment. 2, 10, 20, 30, 40. There it is. Okay. That's not too bad. So then it's about the next set, which is also going to be similar to the C number, but in the other direction, to the C numbers. So, what do we got? What do we got? What do we got? What do we got? What do we have? This number. So this is where keeping track is tricky. 5. And these numbers are smaller? No, larger. Yeah, larger in this case. Again, I've lost track. So it's between this number. So 44.5 and 180. And so 180 and totally lost track of what I'm doing. All right, 2. No, because it's bigger. So it's 180. So what are the numbers? So let's put them in order. So again, so we C, D, and then E is here. Again, how you order your code is important, because you can see logical connections between. So this is the one that's no good, right? Okay, B. So yeah, so that's the default of B. So we want to adjust these numbers to be closer to this. So yes, so that's a 5, and this is a 6, and this is a between 1. The XI 170, 0, and with okay. So we don't actually have a great 70. What is it? 70, 80, 90. We don't have as much of a logical. All right, so let's submit that and find out. $99.7%. Oh, how irritating. I feel very disappointed by this. All right. Okay. So what are we doing wrong here? Sure looks good. This may be one that I redo, or that I don't upload. Nah, I upload these, even if I, there's always a lesson in here. But it is very difficult to see a problem here. Could it be something like these 0.4s? Let's try that. I don't think it's that, but it could be that. That's 100% match. So the visual on the 0.5 looks like it's more correct with the 0.5s, but in this case it's not. So, all right, now that we've got that, I think we do have an algebraic series here, and so we're going to do, so each one adds, so this is plus 10, right? And this is minus 20. And that 90, the x is what? So 0 to 90, plus 90, and then plus 80. And then in terms of the sequence, this is also plus 10. That's also plus 10. That's plus 10. This is plus 20, or this is minus 20, and this is minus 20. And that's minus 20, and that's minus 20. So that's great. That's a great algebraic series. And then this one starts at, it does a plus 90, and then it goes from 90 to 180. So this is plus 80. And then we got this series, which is plus 70. And then this one is plus 60. So how do we turn that into some calcs? We can do that with some calcs. All right, so the top value then is the y value. So let's say f is the factor and it's 1. And then this is f as a factor and it's 2. And this is f and a factor, it's 3. And this is f and a factor and it's 4. Great. Now that I got that f, I can say this top number is 44. Oh, and then I need a factor, a default factor of 0. I'm going to do a calc. I'm just going to remind myself what that was. It's 44 times, no, 44 plus bar f times 10. And does that need to be another calc? Be 10 pixels? What am I doing wrong? And this is also pixels. There it is. Now, can it work without the pixels? It cannot. So we need the units there. So there's your little reminder that calc is a little, when using calc to create values, you might have a little more trouble. Does that mean I can remove this calc, this paren? Yes, I can. So we got 3 numbers, 40. So order operations, do the multiplication, and then we add a 44, and then we're there, which I love that. That's great. And what that means is I no longer need the y variable. So I can just go remove those and get the same result. Goodbye, y. Okay. Next. This is the left value. The x value. So the x is the most complicated. So we'll do that last probably. Now we'll do the h value. So very similar. I'm going to comment out how h is currently done. And I'm going to do a calc of 180 pixels minus a bar of f times minus 20 pixels. No, this is the, yeah, yeah, so height is once so the minus is handled with here. So okay, so by 20 pixels. I was trying to figure out where that went. Okay. Okay, so then that's actually working. So so now we don't need the h. Goodbye the h variable. FFH. Goodbye. Hold on. H I'm getting rid of. Yeah, there's H. So I've gotten rid of all of them. And top is Y. Oh, and I didn't get rid of this one. So that Y can also go away. All right. All right. So that's fun. I like using calc for these. So next, the last one, and and here's another one. I no longer need that to be a variable. That was useful during debugging, but not useful now. I guess I could also make the width this same calc, but I think aspect ratio :1 is clearly simpler. All right. Lastly is the x value. So the left value is 0 plus so I want that calculation to be valid even for this one. So times 60. So reverse. I'm trying to do this without pen and paper. I'm doing it in my head, so I have to concentrate a little bit more. Apologies, so I'm less verbal as I sort this out. I will say that for often, something like GitHub Copilot would be good at sorting this out, but I've also seen it fail at this kind of reverse engineered algebra as well, and I end up going to pen and paper. I'm sure that the LLM-based tools are getting better all the time. Of course they are. All right, let's get to the x value. Enough hemming and hawing. So this is a calc. Right now it's got no value. So it's plus 60 pixels. So var a factor, so a base factor, so 60 is the floor, and then we've got an in parentheses var dash dash factor times 10 pixels. And do I need another calc around that? No, I don't need the point with this 0.60, do I? So 90, 170, 240, 300, 95, okay, 0, 90. So what I want is a calc of a var factor aha. So that's the naive, but it increments with each one. So 60, we need the factor in here twice. Times nope. Okay. So I'm not talking out loud, which is making my code worse. Oh, and is there actually a factor here going on? 0 times, so 2 times what is 160? 160. Really exposing myself here. Is it really just that? No. Yeah, that's just slightly wrong. Again, it's plus. I'm trying to account for the 0, and I'm not knowing exactly. Does that mean I need to start at a different number? Oh, yeah. Okay, so apologies for making you wait on this one. I guess I could I mean, I had a working solution, but I would really like to get this right. So So 60 pixels plus 10 pixels times bar F. Is that correct? Oh, because it gets less. So playing with the numbers. Oh, I feel like I'm on the verge. But again, doing it as I am in this sort of half-hearted way. Minus 10 times 0, 0, 0. All right. Okay, so I'm gonna just keep hemming and hawing here. This is really on the weak side. So that's working for the first one, 100 plus it just feels like that should be working, and I'm not seeing. So I have to need. I think I need the truth table here. Oh, it's additive. It's a kind of a recursive series. It's right. So I think it's time to admit that I am not smart enough to quite do this. So we're going to stick with the dash dash x. I think there's more of a calc there than I want to do. So I'm going to declare bankruptcy on that solution. It's starting to look a lot longer than just a bunch of variables. But clearly there are ways to do series like this. A developer, artist of my acquaintance, Fractal Kitty, is a genius at stuff like this. And probably, if she ever encounters this video, she will scoff at my poor algebraic sense, but that's okay. I know I've got limitations. All right, let's minify and unit play. Oh, wait, whoa, I minified and clobbered everything. I think it's the calc. So calcs and space don't totally play well. Got to have those spaces in the calcs, but not when there's a bar. All right. Be that as it may. That was super fun. So yes, this is an example of the kind of fun that I have and this is definitely one that I will reapproach and see what is the mechanism to reverse engineer the right numbers here, and is there a nice calc which is verbose, right? Like, this is a lot of code to do this calc for the ones that work. I think that there's, because it's a decreasing addition in the series, that reverse engineering the math makes it pretty long to actually get it right. But regardless, all right. So this is a fun one and definitely feels conic gradient to me. So I'm going to go with the nested template, and we will start with a background of like so, and then I'm going to use we'll use the blue color, and we want to use margins to get this right where we want it. 50, 60, 65, 6, 67, and then 65, 66, 67. Oh, even better. 67. So now what we need is a conic gradient, right? Conic. And I think we do a from, it's like 30 degrees or something, like from 30 degrees, so we're just going to spitball it. 30%. And then there's red, 0, 50%. And then white, 0. So that's all wrong. That'll be 75, something like that. All right, so let's get these numbers right. 4, 5, 6, 5, 6, 61, 59, 59 degrees. Love it. All right, so what's this number supposed to be? 20. 10, 20, 10, 13, 14, 15, 16, 17. I have had trouble with closely aligned things like this. Let's do it in degrees. 20 degrees. 30, 40, 50, 60, 61, 62, 62 degrees. And then 180. 50%, or is it 75%? 75? Oh no, it's how come also 50%? That seems like it would be 50%. Oh, because of the from? No, because it's not. Oh, okay. So do we want to? Maybe we want to start it at red so we can actually use that. I like that idea better. Alright, so I'm rejiggering the numbers. 50%. Kill the leading comma. Alright, so here's the parts. So let's go another, let's 100 degrees, 10, 20, 121 degrees, great. 50%, and then whatever this value is, 0, 70%, and then another color stop, so 70, 80, 83, 83, 82, 81, 83, 0.1, 0.2, no, 82.5, 6, 7, 8. All right, let's submit that and find out we got it. I like that round number of 50% for this purpose rather than screwing around. All right, let's minify and unit replace. And that is how we do it. I like that one a lot. That's a good one. Hello. There we go. And that's a good score. Again, from in a conic gradient, you do need to set in degrees, and then the color stops you can do. So this could also be 180 degrees, but that is more code than 50%. All right, and then lastly, I have done this one as 2 elements that are flopped with variables, whatever. Today, I really see the nested template as an optimization. Actually, I don't even see that. Let's do a radial gradient, and we'll do 2 radial gradients. Right? Yes. 2 radial gradients. So we're gonna do. The first part is circle at 50%, 100%, and we're just gonna do that's the orange, and then the white, and I guess they're both orange. That first one is a red orange. All right, so we're just gonna do the base thing, 40 pixels. Let's do it in Q. Why not in Q? 40, 50, 60, 70, 80, 90, 100 Q, 100, 103, 4, 5, 6, 7, 6. 106 Q, and then the next number, I want to need a color stop here, 120 Q, 50, 55, 56, 57, 58, 59, 159 Q. So that's our start. And so we need another radial gradient that's half of that. And for that one, it's at 100%, 100%. We need a comma between. These 2 colors are flopped. And the background is transparent. Like so. And then we got to move it over. Minus 200 pixels. And there it is. It's nice to have some puzzles that are far easier to do than the the sequence of green circles. So that's one way to do it. There are a bunch of different ways to do this one. This is actually a super fun one to do if you did every variation of this. There's no end to the ways you could solve this. Super great. Minify and unit replace. And I have, again, this doesn't like this code. There we go. Yeah, so we clobbered the 3-digit color there, my minification code. So yeah, plugins are available on GitHub, but they are not perfect. No, but remember, you got undo on your side. All right, so that's a fun series. 3 that I did quickly, 1 that I agonized over, and you get to see me flail, hilarious, and then yeah, these 2 which are great and also could be done many different ways. I mean, there's nothing precluding you from doing that a lot of different ways. You know, with masks and linear gradients, and you know, you could do this with. You should do this with 2 linear gradients too, right? But that's fewer than 1 conic gradient. So anyway, thanks for watching. Hope you're having a great day. Go make a web page, write some CSS. It's really fun.